Okay, chapter 4 is on functions. So functions, don't let the word be like, functions, what is that? It's basically a linear equations, which we dealt with in chapter 3. Same kind of thing happens. When we go through these, I'm going to talk to you about what the book talks about, just so that way you can see how that's explained and maybe use that for reference. But then there's also just a simpler, more common sense way to think about it. So I would prefer you to ingrain that part and just think about it from there. So let's look at the first example here. It says the table shows the number of liters in quarts of liquid. So write an equation to find the number of liters in any number of quarts. Describe the relationship in words. So if you look at this, for 1 liter, let me get my pointing pen. For 1 liter, it's 0.95. So for 2 liters, it's just going to be double that. They're adding 0.95 every time, right? So we've talked about that in chapter 3 as they go up. Each one of these goes up. These go up by 0.95. So whenever you talk about that, 0.95 is the rate of change. That is the constant of variation, if you want to think about it that way. So it says, write an equation to find the number of liters in any number of quarts. So that means liters, there's going to be 0.95 in every quart. So we don't know how many quarts. We don't know. But the amount of liters will depend on how many quarts. This would be the independent variable. This is dependent because this depends on what this is over here. But this is a constant. That 0.95 stays the same every single time. So if it wants to know about how many liters are in 8 quarts, we're simply going to put an 8 in right there. An 8, not a 9. Wow, come on now. Kind of looks like a little snowman. All right, so L equals 0.95 times 8. So if you take 0.95 times 8, you will get that there's about 7.6 liters in 8 quarts. Okay, let's go down here. Again, to me, that's more of the common sense way to do it. They're going to talk on the next one about slope and y-intercept and all that. But I want you just to think about it. So pause it and try the got it. All right, back with me. If it talks about the total cost of tickets to the school play is shown in the table. So write the equation to find the total cost of any number of tickets. So, okay, 1 ticket, $4.50. 2 tickets, $9. 3 tickets, $13.50. They're not giving you any special rates here. It's just each one of them is going up by $4.50. So how much money would it cost to buy 15 tickets? Well, you don't need to just sit and add out $4.50 plus $4.50 plus $4.50 plus $4.50 in order to get to 15 tickets. You can have an equation for that. So the total cost is going to be $4.50, because it's $4.50 per ticket, times how many ever tickets you want. And again, these letters, I'm just putting those in there. You could use X, Y, you can use whatever you want to do. But that is the equation. Now, if I want to do 15 tickets, guess where I'm going to put the 15? Where my ticket variable is. So the cost would be 4.5 or 450 times 15. So using our calculator, I would take 4.5 times 15. 67.50 would be my answer. 67.50. Okay, so it's not quite as complicated if you get past the fact that it's a function or a linear equation or basically that it's math, and just think about it. You know these kind of things. You think about these things in real life, so you've got it. All right, so the next part. The total distance Marion ran in 1 week is shown in the graph. Write an equation to find the number of miles run, y, after any number of days, x. So let me show you the book way first. Book way first talks about picking any 2 points and finding, if you're going to write an equation, probably most often you would write it in slope-intercept form. So you're going to need the slope and you're going to need the y-intercept. So the book way talks about finding the slope, picking any 2 points. They happen to pick this one, and then they also picked this one. And so here's your slope formula. They did y2 minus y1. So 14 minus 7 And then they did x2, which is 4, minus x1, which is 2. So 7 over 2. Sorry, 4 minus 2 is 2. So 7 over 2 will give you 3.5. So that is your slope. So right now we've got this much of the equation, y equals 3.5. Now, to get your y-intercept, you are going to solve it for a y-intercept, which means that you're going to put an x in for 0. Sorry, back it up. A 0 in for x. To find the y-intercept, you put a 0 in for x. If I put a 0 in right here, it's going to cause that to disappear. So then y would equal 0. So here's my equation. Y equals 3/5 x, or I could say y equals 3/5 x plus 0. That's going down here a little bit. So that's my equation. Y equals 3.5x. I said 3/5, and I didn't really mean to say that. Sorry, it's 3.5. Okay, so find out how many miles Marion run after 2 weeks. Well, if they run this many per day, that's a day, you would have to convert 2 weeks into days. That's the reason why there's a 14 right there. So do not just put a 2. They're not going to run 7 miles in 2 weeks. They'd run 7 miles in 2 days. So 3.5 times 49, that's what you got. Now, again, that's the book way of doing it. So let's go back to the top here so that way we can see this. And I want you just to use a little bit of common sense that goes with this. Okay, let's clear this off. Use a little bit of common sense that goes with this. Write an equation to find the number of miles run. So that is a total, right? So that's going to be my y equals for after any number of x days. So you know to get a total number, aren't you going to take how many they do per day and times it by the amount of days? So look at this. How many did they do per day? When x is 1 day, x is 1, they did 3.5 miles. That's our equation. When they want the total amount of miles run, it's 3.5 miles times the number of days. That's what you've got. That's your equation without having to do slope, without having to do y-intercept. That is your equation. Now again, if you want it after 14 days, you're just going to substitute in a 14 right there and multiply it out. So the rest of these can be done the same way. You can use slope-intercept if you want, as far as finding the slope and finding the y-intercept, or you could use a little bit of common sense method. So I want you to try either way you wish, but I want you to pause it and try this. Got it, please? All right, let's talk about this. The number of trees saved by recycling paper is shown. So a little bit of common sense on this too. These are direct variation equations because they are going through the origin. Think about this for a minute. The amount of paper recycled in tons equals the amount of trees saved. So what if you recycled 0 tons of paper? Well, you're not saving any trees. So that is a point right there. All right? So if I'm talking about writing an equation to find the total number of trees, y. So that's my total. So y equals, how many am I saving per ton? So for 1 ton, how many am I saving? 17 trees. So 17 trees times x. I don't have to put those parentheses in there, but that would just tell me that's my number of trees, right? Sorry, that's my pounds I'm recycling. So total number of trees, that's my y-axis right here. The total number of trees depends on how many tons of paper I recycle. So y equals 17 tons per each one of these. That is your equation. So for D, find the equation on how many trees could be saved if 500 tons. Well, that just means you're going to put a 500 in for the x. So I've got 500, not 5,000, 500 times 17. 8,500 trees. A lot of trees. All right, let's go down here. This basically just talks, basically just talks in general about the key concepts that are in this lesson, and that you can use words, an equation, a table, or a graph, all to display the same information. So distance traveled, so D is equal to 12 miles per second. So every second, 12 miles. 2 seconds, 24. 3 seconds, 36. Or you could display that in a graph. Every second, 12 miles. So 2 seconds, 24 miles. 3 seconds, 36. Or if you just want a general equation, you could say the distance traveled, D, is equal to 12 per second. So if you went for 100 seconds, it'd be 100 times 12. If you did it for 3 seconds, it'd be 3 times 12. That's where that 36 comes from. Okay, so it's just saying that the representations of these equations, of these relationships, could be done in words, a table, an equation, or a graph. All means the same thing. Maybe just depends on which one you understand better, which one you prefer, because it could all be that way. All right, one more we are going to try before we're done. This talks about Chloe. Oh, Chloe. Chloe's my daughter's name, my middle daughter, actually. She's very cute. Looks just like her mom. She's quite sassy, though. I think she gets that part from her dad. I don't know. Don't tell him I said that, though. All right, Chloe competes in jump rope competitions. Her average rate is 225 jumps per minute. So let's use some common sense here and write our equation. Total amount of jumps, J, is equal to 225 jumps per minute. So 225 jumps for every minute that I'm doing it. So if I do it for 2 minutes, I'm taking 2 times this. If I do this for 5 minutes, I'm taking 5 times 225. That will give me a total. All right, so here's my equation. Exactly what they have right here. 6, make a table to find the number of jumps in 1, 2, 3, 4, or 5 minutes. So 1, 2, 3, 4, 5 minutes. Basically, for each one of these, I will put a 1 right there. So in 1 minute, 225 jumps. 2 minutes, 2 times 225, 450. And I'm going to do the rest with this. 3 times 225, 675. And then that's where they get these right here. 4 times 225, 900. 225 times 5, 1,125. So then they want you to graph it. Now, graphing something that goes up to 1,000, you're going to have to be very creative. So they've got right here, they've got the increments going up every 200. Okay, so the X's 1, the Y's they did 200s, and then they kind of guess. So 1, 225 is just barely over the 200. All right? So let's think about this. Go down to got it. I want you to try this one last example, and then we are done for the day. All right, so back with me under got it. Paul earns $7.50 an hour working at a grocery store. So what's our equation? He does $7.50, so his amount earned, his money, let's say money. His money is $7.50 for every hour that he works. So his money is $7.50 times every hour. So if he works 2 hours, 2 times $7.50, $15. All right, so, oh, look, I didn't even see that part. I am just so psychic. M and H. All right, so there's our equation for E. Make a table to find his earnings if he works 5, 6, 7, or 8 hours. So we're talking 5, 6, 7, 8 hours. Okay, your constant of variation, that's what you've got here. You've got 7.5 times 5, 7.5 times 6. Okay, and you're going to carry that on down. So times 7 times 8. You're going to multiply these out. All right, 7.5 times 5. Clear this off. 7.5 times 5. 37.50. 7.5 times 6. 45. 7.5 times 7. 52.50. 7.5 times 8. 60. Okay? 60. So to graph that, you are then just going to come over here and plot your points on the graph. All right? So functions, not bad at all. Use a little common sense. You will be fine. Good luck.